When I was a child, I had two dreams. One was to travel around the world, and the other was to see robots and humans walking side by side on the street, just like in science fiction movies. Now, GPT-5 has been released, and at the launch event, Sam Altman said that this AI's IQ is already at a PhD level. Doesn't that sound especially impressive? Will the smartest AI soon become your ideal roommate in the future? But hold on a second. Recently, SenseTime published a paper specifically evaluating GPT-5's spatial intelligence. Simply put, it tested whether GPT-5 can truly understand the three-dimensional space of the real world. And the result is still a bit lacking. So even though GPT-5 is very smart and can help you solve many complex tasks, when it comes to helping you move furniture, walk around, or understand the complexities of the real world, it might still have some issues. This paper explored 6 aspects of human spatial understanding measured across several different data sets. GPT-5's scores are still quite far from human capabilities. Let's take a look at what these abilities are. First, let's look at the 2 tasks where it performed relatively better. The first task is metric measurement, which means giving the model a picture and seeing whether it can understand the distances between objects or the actual size of objects in the image. Take this example. We want to measure the height of region 1. The ground truth answer is 2.7 meters, and GPT-5 can roughly estimate this height, responding that it's about 2 meters tall. The second task is spatial relation, which tests whether the model can understand the relationships between objects in the 3D world based on a 2D image. In this example, what we want to determine is which is taller, the house or the clock in front. The correct answer is that the house in the back is taller, and GPT-5 can also roughly guess that the house in the back is actually taller in the real world. It is able to predict this answer. These 2 tasks are ones where GPT-5 performs relatively well, but for the other 4 tasks, its ability is still far behind that of humans. The first is the mental reconstruction task, which is about whether one can reconstruct the true appearance of objects in the 3D world from a 2D image. Take this example. We provide a 2D picture that contains many building blocks of different colors and shapes. We hope that GPT-5 can reconstruct these objects so that when viewed from above, it can determine what the positions of each object would look like. But we found that GPT-5 is unable to accurately understand the true positions of these objects. Or, for example, we provide a picture of these building blocks and want GPT to select what the color distribution would look like when viewed from above. Similarly, GPT-5 is not able to properly understand what the object would actually look like from a top-down perspective. The second aspect is perspective taking, which refers to whether the model can understand changes in the viewpoint or camera angle. Take the following example. In the first image, we photograph the object from one perspective, and then the photographer takes a step to the left and photographs the object again from a different angle, this time from the left side. Can the GPT model actually understand the relationship between these 2 images? From the photographer's perspective, how did the camera move? Obviously, the GPT model still cannot understand the movement of the camera. In other words, GPT is unable to comprehend the relationship between the first-person viewpoint and the actual relative positions of these objects. The third task is disassembly and reassembly, which is about whether it can understand what an object will look like in the 3D world after we deconstruct or assemble it. Let's take this die as an example. Each face of this die has a unique symbol on it. What we want to ask GPT-5 is, if we reassemble it into a 3D die, what should it look like? It needs to pick the die that looks the closest. Obviously, GPT-5 can't do this either. The second example is, if we have 2 building blocks and we want to combine them, what might they look like after being put together? Clearly, GPT-5 can't do this either. But for humans, it's actually very easy to understand that the answer should be option C. The last example is comprehensive reasoning, which involves memory as well as multi-step analytical tasks. This is still quite challenging for the GPT-5 model. Take this example. There are quite a few building blocks of different colors in this picture, and our question is, how many blocks are there in total? Even young children can easily answer that there are 8 different blocks here, but for the model's understanding, this question is still too difficult. Its abilities still need further improvement. So AI models still have a rather limited understanding of the world as it is today. Many scientists believe that current AI models are trained using images and videos and lack training in the real world, which leads to a very limited understanding of the real world. World models were created for this very reason. Scientists hope that by allowing AI to learn and interact in virtual worlds, they can further improve its spatial understanding. Perhaps in the near future, robots will grow and learn alongside us in our daily lives. What do you think? What are GPT-5's capabilities like? Would you like to live with robots? Leave a comment below and share your thoughts. See you next time.